In this video, we're going to talk about the for loop. We're only going to focus on the syntactical aspects of the for loop in this lecture. If you're looking for conceptual aspects of working with loops, please refer to my while loop lecture, and you'll find many of the items in that lecture are applicable to the for loop as well. So let's get started. What I'm going to do is, in Visual Logic, is go ahead and insert a for loop, and you'll notice that it's in the same location as where you find the while loop. And the real difference between a while loop and a for loop is that a for loop is intended to be utilized in loops where you have a very defined beginning and end. Again, all rules are meant to be broken, but we know that, for example, say we have 10 students in a class and we want to process all 10 students. We know that we need to run the loop 10 times. So loops tend to work very well when we have a defined beginning and end. So for loops work very well when we have a defined beginning and an end. And what you'll notice, the syntax of the for loop is such that it's going to make that really easy for you to deal with. And what you're going to notice are a couple of things. Within the structure of the for loop, it's going to ask for a variable name. And this variable is going to be our loop control variable. It's going to be the variable that we utilize to determine if the loop should continue or if the loop should stop. So I'm going to use the variable name I, lowercase I, which is a classical name for a variable in a loop. I think it stands for iterator, but it's pretty easy to read, and we'll use that as our loop control variable name. And one of the things you're going to notice then we have to deal with the initial value and the final value of our loop. So like I said, for loops do very well when you have a defined range. You know where to start and where to finish. So my initial value in this loop is going to be 1. I want to start at 1, and I'm going to end at 10. So this defines our range. So we've got 3 things defined right now. A loop control variable that's going to contain a given value at each iteration of the loop, or each time through the loop. We're going to start our loop at the number 1. That's our initial value. And we want to end it at the number 10. That's our final value. And then finally, the one other thing that's important is step. What I want to do is, if I'm going to start at 1 and go to 10, how do I want to get there? Well, in my case, I want to go 1 at a time. I want to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to use a step of 1, which means this will visit every number from 1 to 10. If I changed it to 5, well, we can see how that changes it. But this is basically, are we skip counting, or are we just counting by 1 from one end of the loop to the other? And what will happen is, each time the value that we're currently looking at, the first time through the loop, our value I will contain the number 1. It'll then be stepped by 1 or increased to 2, and then the value I will contain 2. So what you're going to notice, where we start is at 1, where we end is at 10, how we get from 1 to 10 is in steps of 1, and then the value at each point in the loop will be stored in our variable I. And these are all the components that we needed to have available to us in a while loop, but as a programmer, we were required to put the syntax in ourselves. The only thing that we managed to or get with a while loop syntax is the condition under which the loop should be terminated. In this specific case, in a for loop, the condition for which to terminate the for loop is implied, and basically the condition for when this loop should stop is when we've hit the final value. So while our loop control value I is less than our final value, we want to continue looping. So there's an implied condition here. We don't need an explicit condition. We just know that when we get to the final value, we're done. So what I'm going to do is I'm going to put an output in here so that we can see what the value of I is each time through our loop. And for this specific output, I'm going to use console output. And I'm going to, for right now, just print the value of I on its own line. So I'm going to push this new line character down, hit enter so that we get a new line. And now if I run this, let's see what we get. And the question you should be asking yourself is the number 10 going to print, or am I only going to get 1 to 9? So let's see. Let's run this and figure out what we get. And you will note that this program produces 1 through 10. So one of the things you will note is that the final value here is inclusive. And so what this means is the implied condition is actually while I is less than or equal to final value. In other words, this loop went from 1 to 10 inclusive. And we can see that by running this program. And I will move this back over here. So the first time through the loop, we start at 1. 1 gets put into the variable I, and I is output to the screen, and we get 1. Come back up. Step I by 1. So that's basically like saying I equals I plus 1, which gives us 2. Come over here, print 2. Come back up. All right, step by 1. Well, 2 plus 1 equals 3, and so on. And we're going to end up with this loop occurring in this situation. So that's really cool. And we have this really nice capability with for loops to have this controlled setting. If we want, we can get input from the user to determine where we should stop. I'm going to name this FV for final variable. And what I'll do is, let's make that a console. And one of the things I want to point out is in for loops in Visual Logic, your final value, initial value, and step, all these items can be read in by the user. So in this case, or can be variables. So these don't need to be hard-coded literal values. So I'm going to use this final value variable, and I'm going to run this, and now let's see what we get. And I'll enter, how about the number 99? And when we run this, now notice my loop goes from 1 to 99 in steps of 1. So again, the exact same thing that was happening before is that I start at 1, but now my end value is 99. So we have a defined range, and we can defer how that range is defined to the end user. So it's kind of an interesting way of using variables and using loops. Let's take a look at nested loops. You can put while loops inside of while loops, for loops inside of for loops, and while loops inside of for loops, and for loops inside of while loops. And so what I'm going to do is get rid of that user input and put one loop inside of another loop and change some of these variables. So this is going to be my outer loop. I'm going to name that variable outer. And then what I'm going to do is go in here and I'm going to put another loop, and I'm going to call this loop inner. And I'm going to name, I'm going to do, this loop will only go from 1 to 5. How's that sound? And then I'm going to move my output here. And I'm going to change this so that instead of I, we're going to say outer. So we're going to make sure we can see at each iteration outer loop is, and inner loop is, and I know I forgot a concatenation operator there, so we'll have to add that. And so we should be able to see this running, and we'll see what the outer loop is and the inner loop is and how they relate to each other. And can leave this the way it is because it's still okay probably to see. And so what's going to happen here is our outer loop is going to count to 10. So when the outer loop is going to be set to 1, then it's going to come here into our inner loop. And before we can go back to the outer loop, our inner loop has to count to 5. So it's going to go 1, 2, 3, 4, 5, and it's going to print out this output. And it's going to come back up here when it's done and change outer loop to 2. And it's going to come in here and print 1 to 5 again. Come back up here, change this to 3, come back in here, run 1 to 5 again, and so on. So let's see what this looks like in terms of running our program. And even though I forgot some spaces, which I keep saying that you should not do, I keep doing, what you'll note is you can see, in fact, let's fix that because it'll make it a lot more readable. I forgot to put a space here. And I'll put a dash in too, just see if that makes it a little more readable. And so what you'll note is that for my program, if I push this up here so it's easier to read, you'll note that the first time through, outer loop, notice that the outer loop is 1, and so these items are 1. But then notice the inner loop runs, and it goes 1, 2, 3, 4, 5. Well, notice my outer loop is paused. It's waiting for the inner loop to get its work done. And when this is done 5, it comes back out to my outer loop, and outer loop becomes 2. But then when it gets to the inner loop, it's got to print to 5 again. Once that's done, it can go back out to that outer loop and increment it to 3. And then it has to come back in and print the inner loop, which has to go to 5. And you'll note that the outer loop is printing, we can call it slower, but really it is executing this inner loop 10 times. Well, what does it mean to execute the inner loop? It means that that needs to print out or to execute 5 times. So, in general, we've got a lot of loop executions happening. And so this little program can kind of give us an idea of how nested loops work. There's no problem with having one loop inside of another loop. And you'll note that a lot of programming involves nesting structures inside of other structures and trying to figure out how we can combine all these unique pieces or these puzzle pieces to solve the problems that we want. So that definitely takes some time, and that's really what this course is about. So as we learn these kind of discrete structures and these kind of specific ways that we can use them, really what we want to do is be thinking ahead to how we can creatively combine these into solutions to our programming problems.